Today we will be graphing absolute value equations using transformations. So our objectives are to identify the transformations in an absolute value equation and use those to help us graph. And remember that we used transformations recently when we were graphing linear equations. These will be very similar with the exception of one additional transformation. Let's define absolute value so that we remember what that is. The absolute value of a function gives the distance from the origin. And remember that distance can't be negative, so it doesn't matter which way you go, like this little man running up here. It doesn't matter if you go 2 units to the right, that's still 2 units, or if you go 2 units to the left, it's still 2 units. So we don't describe distance as a negative distance or a positive, right? We just describe distance as an amount. And that's predominantly where we can use absolute value. Absolute value functions form a V. The bottom is called the vertex. And we usually try to find the coordinates of the vertex, just like we try to find the coordinates of the y-intercept on a linear equation, that being our starting point. The vertex is our starting point for an absolute value function. If I were to draw an imaginary line right down here, right down the middle, that line is called the axis of symmetry. Because if you'll notice, the right side is symmetric to the left side. And that is the axis of symmetry. So your absolute value functions should be symmetric from one side to the other. Now let's look at a table of values and let's look at an actual absolute value function. These are our parent functions. Just like if we had a linear equation, our parent function was, if you remember, y equals x, right? So this is linear. In an absolute value equation, it's still y equals x, only these straight lines on either side represent absolute value. Okay, now I've written it two ways because this f of x is function notation, and we've studied that. And remember that f of x is just another way to say y. Okay, there is no difference. If I were to start with my table of values, let's see how this works. If I take a -3 and I plug it in here, and I can plug negatives, I can plug positives, whatever I want inside the absolute value marks, but what spits out is a positive. Because absolute value, remember, is like distance and it cannot be negative. Okay, so if we have an absolute value equation with our vertex here at the origin, notice that the y value on each of these legs is always positive. So it doesn't matter if I plug in here for x a -3 right here, I'm going to come up with a +3 y value. Or if I plug in a +3 here, which would be right here, I'm still going to come up with a +3 value here. And this is if we translate the absolute value equation so that it is here at the vertex. Okay, so if we go down our table, if I plug in a -2, I'm going to get a +2. If I plug in a -1, I'm going to get a +1. Obviously, 0 will give us 0. +1 will still equal +1. +2 equals +2, and +3 equals +3. By plotting these points, this is where I come up with a V. Okay, so the -3, 3 is here, -2, +2 is here, -1, +1 is here. Here is our vertex at 0, 0. And then if I had my line of axis of symmetry in here, I could just reflect these points over to give me my reflection points. Or I can continue to use my table to plot these other points. 1, 1, and 2, 2, and then we already plotted 3, 3 right there. Now let's look at transformations of absolute value equations. So down here at the bottom, I have compared to a linear equation. We have a next to the x, just like we have a next to the x here. We also have a b at the end. The end here is a k, and I'll explain why we've changed the letters to h and k here. Okay, and we'll kind of go through these and compare those to a linear equation transformations. So first, let's look at our parent function. Notice there's nothing next to the x, just like we said with a linear equation. So what we need to do is figure out what all these letters a, h, and k do to our parent function. Here's a graph of our parent function. Let's identify the vertex. We usually try to do that first when we're graphing these. So our vertex in this is 0, 0. Okay, the graph is not shifted up, it's not shifted down, and you'll see that absolute value equations can shift left or they can shift right. But if you look at this, y equals absolute value x, there is nothing on the end to shift it up or down, and there's nothing on the inside which can actually shift it left or right. So our vertex is 0, 0. That's our starting point. Now let's look first at what this negative does. It's the same thing as an absolute value equation. If we have a negative in front of the a, we have a transformation that is a reflection. So this would also be a reflection. Now one thing that I want you to write with these types of transformations, not just that it's a reflection, but what kind of reflection is it? And I'll show you on a graph. If you have a negative here in front of the a, this entire graph will reflect over the x-axis. So picture a mirror right here along the x-axis, and then take this v and reflect it over, flip it over. So this is a reflection over the x-axis. Okay, very important. Like I said, these transformations will not go away. We will continue to do these with every function. So if you want to write these down, that would be great. Okay, now our a value is just like the a value in a linear equation. Remember that our a value was a stretch or a shrink. Okay, so it's a stretch or a shrink of our slope. So that means that our slope got steeper or it compressed down to the x-axis, which we call a shrink. So if we think about our a value, it's a stretch when it was greater than 1. For example, 2 or 3 or 4 or even 1.5, that's greater than 1. It's a shrink when we have a fraction. So when our a value, and I'm going to say the absolute value, since we're doing absolute value, of our a value is less than 1. That's not a 1. Okay, so when the absolute value of our a value is less than 1, we have a shrink. So that means 1/2, 1/3, 2/3. Okay, those are all shrinks. And I say absolute value because I don't want you to take into account the negative. That's a different transformation. So if there's a negative on the front, just look at your a value. And the absolute value of our a value, if it's less than 1, we have a shrink. We have a new transformation in here, and that's the h. So I want to skip that for a second and go to the k. So the k is just like the b. Notice that it's on the end. It's not in parentheses. It's not in the absolute value. It's all by itself, just like the b in our linear function. And the k will do the same thing. The k will shift up or shift down. So that's what type of transformation this is. This is going to be a shift up or down. So that means when we're looking at absolute value, you take this vertex and you move it either up or you move it either down. And so it's just like the y-intercept. Okay. Now let's think about the h value here. The h value in here is going to shift our function to the left or to the right. And the easy way to remember that is to think about that it's inside the absolute value marks with the x. Okay, since it's in there, that means it's shifting the x to the left or to the right. So this is a shift left or right. And I'm going to tell you here, I'm going to show you actually how to determine which way it's going to shift. So let's look at a graph of y equals absolute value x. This is our parent function, and here is the equation over here. Now let's say I go in here, and I'm going to put x minus 2. Well, it's going to be in here with x, so I know that this whole graph is going to either shift left or shift right. So I want you to make a prediction. Which way do you think it's going to shift if I write it as x minus 2? Okay, let's see if your prediction is correct. So x minus 2. Is that what you predicted? It shifted to the right 2. So right here, this is actually x minus 2. Okay, so let's actually look at another one. Y equals absolute value. Let's do a plus. Let's do x plus 5. Now look where that has shifted. It has shifted to the left. So you can start to see a pattern that whatever the sign is, it's going to shift the opposite direction. So this is x minus 5 in here. Okay, so back to our transformations. Let's go ahead and make a note of that. So it's going to shift left if we have x plus h. Okay, it's the opposite of what you might think, and it's going to shift to the right if you have x minus h. And if you think about this from an algebraic perspective, if we're trying to find the y-intercept, y is always 0. So if I plug a 0 in for y, and I solve for x minus h, I would need to move the h over to the other side to find my x-intercept, which means I would have to add h to both sides. And that is why it's always the opposite. Because to find the intercept for x, the left or right shift, I turn y into 0 and then solve for this little portion. Okay, and I don't expect you to remember that, but that might help you to keep in mind why it is the opposite. Now let's finish off with our vertex. Our vertex is very important, and without making a graph, I can find the vertex just from looking at my equation. My vertex is always going to be opposite h value and then the k value. And remember, it's always opposite h value because of what we did here to figure out our shift left or right. So if I had a function that was x minus 2 plus 3, my vertex would be positive 2 and positive 3. And we'll do some examples. All right, so to finish this off, we'll try 6 examples. We've got these 3, and what we want to do is identify the transformations first, and then graph. So looking at this, I'm just going to look where the numbers are, because I know those will be transformations. We have a 5 on the end, so all I know is that I'm going, and it's a plus 5, so I'm going to shift up 5. And then I will always identify my vertex. In this example, I did not shift left or right, so my vertex starts at 0, but I did shift up 5, so I have a 5 in here. Whatever's inside the absolute value will tell me the x value of my vertex, and since there is no number in there, it stays at 0. So I'll go ahead and put my vertex here at 0, 5, and then I'll show you how to graph easily the rest without having to do a table. So what I will do first is I will look at my slope. My a value is 1, right? There is no stretch or shrink, and it's positive. So I know that, and I'm going to make a note, that this graph opens up. Okay, it's not reflected. It's going to open up. It's going to make a V. Well, my slope right here, since it's nothing, I know that my slope is 1 over 1. And since if we go back and we look at, let's go back to the home screen here, if we look at a linear or absolute value equation, it's really just 2 linear lines. So I know my slope is constant. So my slope here goes up 1 over 1, up 1 over 1, as it does on the left side because everything is symmetric. So I'm going to do that here. I'm going to go up 1 over 1, make a point, and then I'm going to go up 1 over 1 on the other side and make a point. And that's really all I need in order to graph my function. So I will just draw a line from the vertex through that point, and then I will draw another line. And from the point up, and I have my absolute value equation graphed. So very simple to do. You don't need tables of values. Now let's look at the second problem. So we have 2 things going on here. We have a negative and we have a 2. And if you remember that the negative means we have a reflection. And this time I want to say how it's reflected. So I have a reflection over x. Okay, so over the x-axis. And then the 2 means that I have, now think about this, this goes with our slope, It's in front of the a, it's being multiplied, so this is a stretch or a shrink. And if you remember that if it's greater than 1, we have a stretch. So we have a stretch of 2. Okay, so that's going to change our slope. Let's look at our vertex. We always want to get that first point before we start graphing. So our vertex, remember, is h and k. Well, there is no h value in here, and there's no k value on the end, so my vertex will just stay at 0, 0, where the parent function is. So let's go ahead and plot that point. I've got 0, 0 right here. Another key thing then is to notice that our graph is going to open down because of the reflection. So this will open down. Now if we plot our points, my slope is going to be 2 over 1. That's my rise over run. So this time I'm going to go down 1, 2, and over 1 and make my point. I'll go down 1, 2, and over 1 the other way and make my point. I'm now ready to draw my lines. So I will start here at my vertex and connect, and start here again at my vertex and connect here. And that is the graph of y equals -2 absolute value x. Okay, third example. Now we do have something in here where h is supposed to be, and we have something in here where k is supposed to be. So this -1 means we are going to shift. And if you remember, it's always the opposite. So we are going to shift right 1. And then the 4 on the end means we will shift up 4. That one is the same. Shift up 4. The 4 goes with the y, and they're on opposite sides of the equal sign, so we would keep this as a positive. The 1 goes with the x. Since it's on the same side, we would have to move it to the other side to find out the intercept, so we would do the opposite. We would add it. Okay, let's find our vertex. And our vertex is going to be opposite h, so it's 1, positive 1, and then our k value, which is 4. I'll go ahead and plot that point at 1, 4 right here. My slope, if you'll notice, I don't have a change to my slope. It's just 1 over 1. And also, if you'll notice, the slope is positive, so I know my graph will open up. So this is going to open up. And that'll tell me which direction to plot my points. So I'm going to go up 1 over 1, make a point, up 1 over 1, make a point, and now I'm ready to draw my line. And those 3 are graphed. Okay, let's try the final 3 and then we'll be finished. And actually you may want to go ahead and pause and try them on your own and then come back and see if it matches what I have. It would be good practice. Okay, so our first graph, we have a 1/2 in place of our slope. So we know that is going to be, since it's less than 1, that's going to be a shrink of 1/2. We have a value in here next to the x, so that means our vertex will shift left and right, and it's always going to be the opposite. So we have a shift left 1. If we pull our vertex from here, it's opposite h, so -1, and we have nothing over here for k, so that's 0. Now I can plot this on the graph. I will go to -1 for x and 0 for y, so it's right here. My slope is going to be, the other key thing, almost forgot, is to notice that it's a positive slope, so it will open up. So let's plot our slope. We're going to go up 1 over 2. Up 1 over 2. And now we can draw our lines. Okay, and there's our graph. Now let's look at example, this would be example number 5. We have a negative here, so that means we have a reflection. So we are reflection over x. The plus 7, now look where that is. That's on the end. That's not in with the x, right? It's outside. So that means it's a shift up or down. And in this case, we have a shift up of 7. Okay, and then let's find our vertex. So our vertex is going to be our h, opposite h in k. There's nothing in here, so it stays at 0. Our k value is a positive 7. Now because it's negative, because it's a reflection, we know we are going to open down. So it opens down. Okay, let's plot our vertex. Our vertex is at 0, 7 we said, so that's way up here. Our slope is a negative 1 over 1, so we're going to go down and over 1, down and over 1. And now we are ready to draw our lines. Okay, and onto our final graph. Here's our slope. It's a fraction, so we have a shrink of 2/3. We have an h value in here, so we know we're going to shift left or right. And hopefully you remembered to do the opposite. So we are going to shift left 3. Oops. Shift left 3, and then the one on the end, it's a -1. So we will shift down 1. And let's identify our vertex. Our vertex is opposite h, k. Opposite of positive 3 is negative 3. Our k is -1. Our slope is positive, so we know this will open up versus down. And now I'm ready to plot my points and draw my lines. My vertex is at -3, -1, so that's down here. My slope is 2 over 3, rise over run. It's going to open up, so I'm going to go up 1, 2, and over 1, 2, 3. Same thing with the other side, up 2 and over 1, 2, 3. And once again, I'm ready to draw my lines. And that concludes this lesson, and that is how you graph absolute value functions using transformations. The key thing for you to remember is to always find the vertex, which is opposite h, k, understand whether the graph opens up or down, pull off the slope, and you will be able to graph any absolute value equation.